So why have we done zoning so much in the past? As a guy that's been an air conditioning service tech, installer, and sales person for over 40 years, we were installing zoning way back in the day, and that's what was kind of the solution du jour for the problems we were having. And really, it really only gave us a bunch of perceived improvements. We did get some improved comfort, maybe, except when our zone system shut off, one half of the system would shut off and we just get an amazing force of air through one side of the zone system. We perceive that to be energy efficient, but anytime we're moving energy to a place it wasn't before, we're using more energy. So we really kind of thought that it was more efficient than it was. Sometimes it solved some problems. And we always looked at that. It was a reasonable way to deal with houses that had these microclimate issues. So now we know stuff a little better. There's like a lot of new technology around. Common reasons for zoning is you got major climate differences in house, or what we call microclimate zones within the house. Downstairs, if any of you are happy enough to live in a two-story house, you know, it's nice because it keeps everything separated, but also in the summertime gets real hot upstairs. Downstairs gets warm, then all the heat travels upstairs. So we get these microclimate zones. We hear all the time, like, my upstairs is unmanageably uncomfortable and the downstairs barely keeps up. So we started selling zoning back in the day to try to solve this problem, not knowing what it was actually doing. And a lot of times it actually drove the operational cost of the system up. But we didn't pay attention to that too much when energy was cheap. So now we have to deal with this a little better. The other one, you know, we want to section off a part of the house that we hardly ever use. So we'll put that on a zone. We'll turn that off when we don't need it. But then that had problems too, because if you turn on just that zone, then you got this big machine starting to just heat one zone. And so that was problematic. And then also we know those domestic temperature battles, those legendary, the thermostat battles. I will tell you, since I put my heat pump in my house, my wife and I agree on the thermostat temperature, which is really, it probably saved thousands of dollars worth of therapy in the long run. So helps get rid of those if we do it right. So types of zoning that have been around for a while. We've always had like these electric dampers, and then we'd have these zone control modules. These zone control modules would be typically installed on the main system. You would have a damper on the upstairs ducts or the downstairs ducts or that room duct, whatever it was. And we would have one of these modules. The module is kind of the brains behind the outfit. You'd hook the two thermostats up to that, and it would aggregate the information that's given in an analog way and open dampers when you need to and close dampers when you need to. But now we have all these cool new ways to do things like multi-zone heat pumps, variable refrigerant heat pumps, and manufacturer-supported zone systems that actually work with the algorithms of the various type of equipment that's available. So just like all the other technology out there, the zoning technology has really improved as well. And then we have these things out there, and we see these, they're marketed under several different names. They're very interesting. It's basically a remote control thermostat that operates off of a battery, and then you have a register in the ceiling, and that operates a little motor off of a battery. And when your thermostat says shut it off, it stops. It tries to stop the air from flowing through that register by closing a damper at the end of the register, which is the wrong place to do it. But these are really available online, and a lot of people are buying them, and people are asking us about them more and more. So I guess they're spending some money on marketing, but it's really a poor strategy if you're looking for a system that performs. When we install our systems and we design our systems for the house, we're designing those systems so that they have the correct airflow for each room, and then we're designing the capacity of the system to provide that airflow. So when we choke off the airflow to one room, it can often have adverse effect on the rest of the zones in the house and on the performance of the system itself. So they can also be a little noisy because we're shutting the air off right here at the vent instead of back at the Y branch or back at the start of the duct. And our system is still building up pressure behind that little zone damper. So interesting option I think I spoke to Alex earlier today. I think I'm going to try one of these in my master bedroom just so I can get a feel for how it works and see if we might be able to kind of fix that I like to sleep cold problem. But we're going to do some research on it, and maybe we'll deliver some more information on that in a subsequent webinar. So ducted zoning, a few things that you need to be mindful of with ducted zoning systems. A lot of zoning systems were installed back in the day on single stage equipment. And I'm from back far enough in the industry that I remember that that's all there was single stage equipment. I remember having the first meeting with the distributor that was selling us the equipment we had, and they were bringing out this amazing new technology called two-staged equipment. We were going, wow, 2 stages? You can do 2 stages? That sounds really cool. So then we have a high and a low. That will be perfect for people that want something when they need less and have something when they need more, right? We've come a long way from there, but zoning was actually being used way before that staged equipment was available. And basically what a zoning system would do is just cut off half the airflow to the system that it was designed to use and cause all kinds of problems there. So it also doesn't take into consideration things like, it doesn't fix things like poorly installed ductwork from the get-go. So it doesn't matter what kind of zone control you have on a duct like this, you're not going to get the amount of air out of it that you think you are. So we still need to fix those problems on the other side. Just as an industry, we didn't know enough about it at the time to be doing it. So, and the other thing we know here in California, we're blessed with this thing called dry climate. And dry climate, if anybody in the audience has ever spent any time on the East Coast, Texas, or one of those where we have really high humidity in the summertime, that takes a completely different strategy of HVAC install to handle that additional humidity that's in the air, like all this latent heat removal that we have to do with our systems. We don't have to deal with that in California, so we're really blessed, right? So we need systems out here in California that have lots of sensible cooling, which means the energy we're using from the system is actually being used to cool the air in the house, and we're not wasting a bunch of energy trying to draw humidity out of the house. And that's all going to be based on how the equipment is designed for your house and how it's installed and how much thought went into kind of the installation process. And the problem with doing that was we could set up a system that had really good airflow when all the zones were open, but as soon as you shut one of those zones, which is basically choking off half of the airflow in the system, you're really causing that system, instead of, if you think of it like water flowing through a fire hose when the system is fully open, that unit is giving you all the heat that it can, that it's designed to. It's got airflow that's at its design temperature, and then we choke off half of it. So we came up with this crazy solution. Oh, well, that's the next slide. So the other thing we have to worry about is when we're doing zone systems, they're kind of difficult to install, especially the more zones they are. This is one of my favorite pictures. You can see the zone damper here and the zone damper here, and basically all of this high static pressure ductwork that's going all willy-nilly is not a good way to do this, right? We're causing pressure problems in the system that are causing us to use more fan energy to deliver the air in the house, and they're really knocking down the performance of either our furnace side or our cooling side. So the systems aren't designed to work with half as much air. So poor ductwork is a real problem, and putting in zone systems kind of made the ducts worse a lot of times. So this is also an example of poor ductwork that we show in all of our classes. And I challenge my people that are in my classes to try to explain to me why somebody would do this. And the only reason we can all figure out is because they're lazy, right? There's about 15 feet of duct here and about 5 feet with 1, 2, 3, 4, 5, 6 turns. So probably equivalent of about 100 feet of duct and 5 feet here. And so when air tries to make its way down through here and it has to turn, it gets scrunched, it turns again, it gets scrunched, gets turned again, it loses a lot of its ability to travel beyond this point, which what happens is it creates more fan energy requirement to blow the air against these static pressure loads. So ducting, no matter what kind of zoning system we're putting in, is extremely, extremely important. We had this beautiful idea. This is called a bypass damper, and this is back what we were doing on single stage equipment. So what happens here is we have a furnace that runs at one speed. We turn off one of these dampers here, and it creates back pressure in the system. So I don't know if you can see this little rod back here, but this is called a barometric damper. And you were basically supposed to set up this rod with a little anchoring bolt, and you would set up this rod that had a weight on the end. And then when it had back pressure against it, you would offset the weight so there was just enough room for this thing to open. So what we were doing is we had the furnace running here, and it's running fine with both zones open. So that means its heat rise is okay. It's not too hot. And then we close the damper here, and we think by deflecting the hot air that's left over back into the return was somehow going to be beneficial. But what we found happened after these systems were in for a number of years, which is why they're not legal in California anymore. But what we found happened is by slowing down the airflow going to one zone and redirecting the already heated or cooled air back into the return, we now put really hot air into the return of this system, which means the furnace is warming it up more. So the thing would just superheat. And that would cause the unit to go out on overload or limit temperature, which would cause a whole nother set of problems. And in the air conditioning mode, what we'd be doing here is we're taking warmer air from the house, we're bringing it up through, we're refrigerating it, pulling the heat out, then we're sending that cold air back through here, and we're again refrigerating it. So what we had here is super low return temperatures, which caused problems with the coil temperatures, which often cause these units to either ice up, like generate ice on the fins of the coil, or just be so far out of performance factor that you couldn't really look at this thing and say how it was going to perform. But that worked okay back. It was performance checking anything. We put systems in that worked, but that's all we knew, right? The performance factor of a system was the customer not calling back and complaining. And so this was a very rudimentary way for us to get rid of some of the thing, reduce the static pressure in the system, but we were inconsequentially putting superheated or very cold air back into the return, causing all kinds of problems. So a few years ago, they outlawed these, and then they changed the rules around zoning. And what they said was you had to have the minimum required amount of airflow be able to be achieved through either one of these zones when they're open. So the minimum required airflow is 350 CFM. And so if I have a system here that has the ability to push a lot of air, maybe it's a 3-ton, 4-ton system, whatever it is, and we choke off the airflow, and we don't have a bypass damper, we had to make the system smaller. So if one damper was shut, I could still achieve 350 CFM, which really never got picked up by the inspectors. I saw companies still installing these years after the code had changed. But the inspectors really never picked up on that because they don't have a way to test all this stuff. So those type of regulations on the inspectors really don't do any good. But two-stage equipment seemed to help. So if we had a two-stage system here and we used a two-stage advanced zone control system, what we could do is when one zone was closed, we could shift that system back down into low. And when the second system, or when the second zone opened, we could kick the unit back up into high. That was actually not a bad approach, and it made zoning a little bit more efficient and doable and less kind of obtrusive, I guess we would say. So a lot of studies have been done over the years, and what they have found is traditional zoning doesn't really save energy. If you have your upstairs doesn't cool and you put in a zoning system and it's directing air up there to now cool that load, you are now providing more energy to cool load that wasn't being cooled before. So we are effectively using more energy. So balancing all these things out is very difficult. So Procter Engineering did a study way back in 2011, which just seems like 5 lifetimes ago. They found in 4 of 7 heating cases and 4 of 6 cooling cases, the energy consumption increased with zoning configuration. So the majority of systems where zone systems were installed ended up using more energy and not less. We kind of didn't know that when we were doing it, but if we stopped to think about it, we could figure out why. traditional zoning challenges with heat pumps. So we can do this with a 2-stage heat pump, and we could do the high-low zoning, and we can still control staging on the heat pump the same way we can do a dual-stage furnace. But then we run into those same problems where the heat pump not really working well below 40 degrees, and we open up a whole nother can of worms that we have to deal with. So dual-stage heat pumps would work, but they still gave us the similar challenges. But now around 1990, we started getting these units in that we weren't using till more recently, called inverter heat pumps. And we were just kind of enjoying those as the mini split unit that's hanging on the wall that we use the remote control for, like one of these remote controls for the one in my office. That became like a zoning go-to, right? So then contractors were like, I'll just put one of these in every room and it'll be fine. And that creates its own set of problems that we'll talk about in a minute. Then there's also these other ones that aren't communicating inverters. These are called pressure and refrigerant sensing inverters. And these are inverters, there's a couple of trade names out there, but these are inverters that operate off of the refrigerant temperature. So what they do is, if you shut off part of the airflow to the system, the refrigerant temperature gets really cold and cooling, or really warm and heating, and that's what makes the outdoor unit just kind of slow down. The problem with those systems tends to be, and what we've seen, is if they're put in on duct systems that aren't perfect, they never really get to operate in full speed, because it always thinks like that there's airflow issues because we're not moving enough air across our coil. So whole different set of problems. So really the moral of this whole slide here is just follow the manufacturer's recommendations. Some of these systems, these refrigerant sensing inverters, you cannot put zoning on and have it be reliable with certain air handler combinations. So we need those air handlers to be able to adapt to the different airflows. Some of the brands do that, some of them don't. So be careful about that. But if you're adding zoning and you're questioning it, call your equipment rep and say, what do I need to do for the zoning on these systems? Because a lot of these systems require the manufacturer's zoning, because it communicates and it understands the algorithm of the way the system is operating in order to work properly. So don't put the over-the-counter, whatever brand zoning system on a heat pump system unless you've checked with the manufacturer and they say it's okay to do. So follow those manufacturer recommendations. I know as HVAC people, we hate to do that. Like we use instruction booklets and install manuals as knee pads, right? So we got to get systems out there that people know how to install and know which ones we're doing. And at least the first couple times we need to follow some instructions. So let's do that. So ductless zoning. Ductless zoning is what we see happening a lot. So we train contractors all over the state for the Tech Clean California program. And a lot of the contractors come in, they say, and we will talk to them, do you guys install inverters? They say, yes. And a lot of their solutions are a multi-zone inverter with a bunch of units hanging on the walls. They're actually having to do some serious talking to the customers to get them to buy into that, I would think. Maybe I think that because I know that there's limitations, but so this is what we're talking about here. We have multi-zone equipment. And this multi-zone equipment, this particular model, which is a Mitsubishi, really nice system. One of the great features of this one is you only have to run 2 lines to this branch box out of the system. So you don't have to run a bunch of lines around the walls. You can run them to a central location, kind of disperse it. There's also these other stuff that we'll talk about in a minute. But this ductless solution can work in a bunch of different ways, but most of the way we see them is like one of these outdoor unit with maybe 4 or 5 of these indoor units. And we'll get to that in a moment. Multi-zone systems have their advantages and their disadvantages. And I tend to look at everything through what's going to be most beneficial for the customer and what's going to be the most beneficial for the company to actually make a couple of dollars on a job, because we do need to pay our employees and stay in business. So the advantages of the ductless multi-zone systems are they offer pretty good flexibility for multi-room solutions if done correctly. They're really good for houses. When we do these a lot, it would be 1 air handler and 1 unit maybe in a basement room or that room over the garage or a problematic room like the master bedroom where they're not going to be able to get good conditioning in, kind of that problem space, or what we call that additional microclimate zone inside the house. Those branch boxes on some of these systems help reduce line set links, which is a big deal because that material is very expensive, and putting it all over the house is labor intensive. These systems need a little bit less space because we don't have to have a furnace somewhere. We can put these units on the wall, but that doesn't mean that it's overall going to be an easier job. I think people think it's going to be easier. The disadvantages on these are they have a whole lot more refrigerant in them. And now we're really cognizant about this, the global warming potential of refrigerants. And if I can put a system in that has a refrigerant in it that has a higher global warming potential, I want to install a system that has the smallest charge or the least amount of refrigerant in it. And when we get into some of these multi-zone systems, because we got to run these lines everywhere and put these boxes everywhere, sometimes we have to load these things up with, some of them have 20 pounds of refrigerant in them. So if you get a leak and that thing goes flat, we've lost 20 pounds of refrigerant to the atmosphere. The other thing is there's way more chance for leaks. So these units all are going to have line sets that go back and forth. They're going to have line sets that go back and forth. So a typical system like this is going to have 2 lines here, 2 lines here, 2 lines here, 2 lines here, 2 lines here. So that's 10 total line sets, which means that there is 20 lines that have to be terminated on both ends. So that's 40 chances for leaks. I think my math is right there. It's all round numbers, so I should be able to handle it. There's a little bit of an efficiency penalty on these, and they're more difficult to repair because if you got to find a leak in that thing, it's a little bit more of a problem, and the installations are a bit complicated compared to like what we usually do. So let's look at a case study with a multi-zone example. So this is a multi-zone system. This is like a one-to-one multi-zone system, or not, excuse me, not a one-to-one, but a non branch box system. So we have one unit on the outside of the house, and we have line sets that are all over the house going to various places in the house. So this customer has 1, 2, 3, 4, 5 zones, or however many zones it is. Let's just look at a case study that's not necessarily reflected to this picture, but a 1,200 square foot house with 3 bedrooms. And if it has one larger area that's, say, a family room kitchen combination, so we can take care of that with one. So we're going to do a 4-zone multi-zone setup. We have to add the capacity of all of the indoor units together, and all the manufacturers don't make systems small enough for the room loads that we see. When we do a load calculation, oftentimes we're seeing room loads of maybe 1,500 to 2,000 BTUs, and then the smallest air handler is sometimes 6,000. I know that I heard that Mitsubishi is looking on at a 3,000 BTU, but this can be have its own set of problems. So in order to do this and make this work, I would need a 3-ton system. In that same house, that same 1,200 square foot house with 3 bedrooms, if I have access, like a crawl space or an attic, I can put in a single 1.5-ton ducted unit that needs far less refrigerant lines, all the things that we're trying to get rid of. So I could do this house with a 1.5-ton ducted, but since I'm going with a multi-zone, I have to go with a 3-ton system, which just means I'm double oversized. Randy's going to address that in a minute. So the modulation on this system, that means how fast it will go and how slow it will go. This unit's minimum modulation rate is 11,007. If I put in a 1.5-ton ducted, my minimum modulation rate is 5,400. I can slow that unit further down. So what we see here is if I try to run 1 bedroom, this is what people always say is I want to be able to run 1 room at a time. This is what they get sold on, right? Why heat your whole house when you could just heat that room you're in? Well, if you heat that room you're in and then you walk to the bathroom, the rest of the house is cold. So what people end up doing anyway is turning on multiple ones anyway, and then we don't see the problems that exist. But if someone was to try to do the 1 room only solution, we talked to a customer the other day that was looking at that, and that was kind of their thing is like, we're in that office all the time, and my wife's in that office all the time. We just want these little zones, and then we'll take care of the living space with 2 other ones. Well, we looked at the size of the system that they needed. It was going to be like 42,000 BTUs. The modulation rate was at a point here or higher. And so what happens is, if my system will only slow down to 11,700 BTUs, and I want to run one 6,000 BTU head, that means that this unit is always going to be giving you maximum capacity whenever that's happening. So really what we recommend people do is, if you run this 15 and any of these 6s at the same time, then my system can modulate down a little bit and you'll get some effective capacity change in these smaller rooms. But if I have a room that's sized for 2,000 BTUs, and I put a 6,000 in there and I try to run it by itself and it can never give me less than 6,000, then that room is always going to be hot or cold. And then it creates these other problems that I'll let Randy expand on in a few minutes. But in this particular application, it's 16 refrigerant connections, 4 condensate connections, possible condensate pumps and drywall work, just a lot of stuff, right? So here's a multi-zone ducted case study. This is a house that was done back in 2018. And this was my first multi-zone ducted solution. I went in with the same gusto and communication with my customer, and I told them how awesome it was going to be, because this is a modulating system and it's going to heat their house extremely comfortable and it's going to be awesome. And the first night that this was installed, the house, I got a call from the customer and she says, we are not comfortable and this is not awesome. So we went out and looked at it, and not understanding all of this at the time, this was the learning event that kind of brought this whole part together. She was getting very erratic temperatures. Part of the house was more efficient than the rest of the house, and she had a small unit in the master bedroom and a unit for 2 bedrooms and a bathroom on one end. That part of the house was not well insulated and not well sealed. The rest of the house had been remodeled and all the walls were insulated, so it was a much tighter envelope. So it caused this whole thing to do this weird stuff. The bedroom side was continuously calling for heat. The heat was bleeding over into the other zone and it was overheating their master bedroom. And then, because it couldn't keep up, kept going into defrost. It was all kinds of problems. So when we have a minimal refrigerant flow or a downside BTU rating on this unit that exceeds the size of any of the indoors, whether they be ducted or non-ducted, it is going to overproduce in those areas. And so she said the problem was happening around 10 o'clock at night. And I says, this lady doesn't like me. I'm not going to ask to spend the night over there. So we invested in a data logging machine, and we set the data logging machine up in there, and we put the thermometers throughout the house, and we just wanted to get a feel for what was going on. And so this was the moment in time on February 16th, 2028. It was one day, 8:44 a.m. to the next day at 8:44 a.m. And you can see what was going on. This house was dipping down to temperatures that were really, really low at night. And it was recovering to the point where it was really fast, like trying to heat back up, getting to its peak, going into defrost, diving again. So it was doing all of this crazy stuff. And once I got this data logger on here and I go, wow, you're not kidding. This doesn't look comfortable. So through trials, tribulations, pulling out people from the manufacturer, changing some boards because there was a possible issue with that, adjusting things with the defrost wherever we could, resetting a number of dip switches and settings on the thermostats, we didn't get any real benefit out of this. And you'll be able to see on the next picture how long this took us to fix it. Fortunately, this was a customer in Napa and they didn't live in the house. So our whole thing with her is we would like to learn from this and fix it right, but can we do a little bit of research on it and figure out what's going here, because we want to know what's happening here so we don't do it again. And so what ended up happening is ultimately I had to take out the multi-zone system and I had to put 3 outdoor units that matched the indoor units. And that was going to be the only solution after we had done all this other stuff. I mean, I had a rep from the distributor out there that was really sharp about the systems. I had the manufacturer's rep come out. Everybody had differing ideas of why this was happening. I think it happens at a lot of houses, but people just don't bring it up. And I didn't, I had the data logger page, so people were going, wow, this is crazy. But it was an expensive lesson. We had to take out a unit that the company paid for and put in 3 new outdoor units that the company had to pay for to get this customer satisfied, and situated. It's a hard, expensive lesson. Instead of the 11,000 BTU downside modulation rate, I now have 3 systems in here that will downside modulate all the way to 3,100. So now each zone in the house was getting exactly what it needed. And we reached this amazing true comfort. And I still use this slide today to show people how these systems work. So this was the final thing. Big unit out, little units in. This was all done, fortunately, and thank you to my previous employer. We learned this at this hard lesson on a job that was put in there, which thank goodness. This was an expensive lesson, but we all learned it together. This was the outcome. So we didn't put a thermometer monitor on the master bedroom register, but what we have is these are thermometers of the 2 registers in the main living area and the bedroom side that was less efficient. And what you can see here is with my units operating independently, and all of them, I think we ended up setting these things for 72 degrees. And we were maintaining somewhere within 1.5 degrees all the way through the house of 72 degrees. We've got a little 73 in one room, 71 in another, but we're really around 72 degrees. What you can see here is the actual modulation effect of these systems. So house is getting a little warm. Thermostat tells the unit, hey, you need to slow down. The actual temperature of the air coming out of the register reduces over a short period of time from about 84 here to about 76. And then as the house is what we call tempering here and everything's getting where it needs to be before it gets into this amazing state of thermal equilibrium, it's making its little adjustments here, getting a little cooler, getting a little warmer. Right around here at 8 p.m., it's starting to decide what it's going to do. But right here at about 9:30, it starts doing what it's supposed to do. My temperatures get really, really even in the house, and my systems are, they can downside modulate to the point where they're just keeping it comfortable. And in the really high side, the high performing side of the house with all the good insulation in the walls, we were able to maintain the temperature in the room with air that's just 7 degrees warmer. And in the less efficient side of the house, we were able to maintain the temperature with air that's just 11 degrees warmer. So I use this slide to show my customers like the benefit of having 2 systems in the house when there's 2 climate zones and having them operate independently of each other. And the other part is, this is really a great visual of how these units modulate, right? How the temperature from the register changes as the house acclimates. And realistically, if you live in a house with multiple zones, who doesn't want to live in a house this comfortable? These systems can find their own way. It was a beautiful finish to a really testy situation with the customer. And you can see the date here, 3/7 of 2018. By the time we figured all this out, figured out a game plan, went through all the trying to do all the repairs, it was a month later when we finally fixed it. So from our experience, when we're using inverter technology, most common residential applications, it's best to do a 1-to-1 system in each zone, especially when we're doing ducted technology, right? So I tell you, these are all ducted systems that we installed here. So I like one ducted system for the majority of the house. Sometimes if there's a big room that needs a different climate zone, a good wall mount in there if we're going to do a multi-zone. So one ducted and one multi-zone, or excuse me, and one wall mount. Multi-zone units are better when with limited air handlers or situations where multiple we run at the same time, is what we found. And that we want to avoid multiple ducted air handlers on one multi-zone system. The thing about the ducted air handlers that are unlike the wall-mounted ones is most of them have to have some air moving through them all the time to sample the air. So if the refrigerant is flowing to one that unintentionally, because it's over capacity on one of the other zones, that refrigerant goes somewhere. So if I have a fan that's moving continuously in that unit, it could give us unintended heating or cooling in those rooms, and that's not what we want. So I want to just expand on this for one more minute. So in houses where we're doing ducted systems, there's certain things that we need to do on this. If I've got 2 small systems, This particular house has an 18,000 BTU for the upstairs, and it's a fully ducted slim duct system. When we design these, we have to design them for their lowest operational capacity internally. So we have to do load calculations to determine room by room airflows so that we can dial the airflow into each room. So with our longer run times, we're going to make even temperatures within the house. We have to design them with large return airs coming in so that we can keep the static pressure as low as possible in the system. And that way the system can actually operate at the stated capacity. So if we put one of these units in and it's designed for 0.3 inches of static pressure, and we put in a zone system, or we put in a duct system that brings it up to 0.4, 0.5, now that unit is operating out of specification, and we can't go and say we know what that is going to do. So it's incredibly important that we reduce airflow in these systems and reduce static pressure in the systems to make sure that they operate better than manufacturer. So what we try to shoot for is if a system is rated at 0.3 static, which those are hard to find now because of some recent rules with the federal government. If we do that, I want to shoot for less than 0.2 static pressure. If I'm less than the static pressure needed or tested for the system, my system is going to operate better than spec, and it's going to be more efficient than the specifications are going to say it's going to be. What happens with these is we want to look at not only the outdoor unit energy, but also the fan energy. When we do things like putting the wrong registers in the rooms, putting the wrong type of return air grill that's restrictive, or putting a face filter in a return air grill that can easily load up, it's not a thick enough filter. Oftentimes, we cause higher than normal static pressure, which drives down everything. And then it doesn't take much for that filter to get dirty and cause even higher static pressure and throw everything out of whack. So when we're installing these systems, we are also using very thick MERV 13 filters that come in a cabinet. And those filters are actually designed for much more airflow than our systems are specified for. So oftentimes I'm putting in a unit here that is 18,000 BTUs. This unit is going to give us roughly 600 CFM of airflow. I'm using filters that are designed for systems with 1600 CFM. So when I do that, there's very, very low pressure drop across that filter if I use the right size return. And that means the filter can even get dirty and the system's still going to perform well. So we always shoot for numbers below so that we can get performance way above. So that's a couple of takeaways there. The other thing is we want to make sure that when we communicate with our customers about zoning, we always talk about microclimate zones inside the house. We always talk about because we have customers, I got 3 bids. They want to put in, one guy wants to put in a 4-ton, one guy wants to put in a 3-ton, and the other guy is going to put in a 3-ton Mitsubishi, whatever it is. And I'm like, well, you have a 2-story house. Does it ever get warm upstairs when it's not warm downstairs? And the customer will say yes. And does it ever get cold downstairs and warm upstairs? Or vice versa? Will you ever see that there might be a time when you might want air conditioning upstairs but not need it downstairs? Is there a time you think you might want heating downstairs but don't need it upstairs? These are the conversations that lead us to being able to talk to a customer about zoning and then get to the point where we're talking about multi-zone, which means 2 systems. So a typical 2-story per house for us, even if there's a furnace in the attic and it's got an existing zone system on them, I always include an option for 2 separate systems. So I'll have a system for upstairs and a system for downstairs. A lot of times we'll put in a traditional air handler laying where the furnace was, and then I'll hang a slim duct air handler above it. And I'm actually taking care of that dual zone with 2 systems. So if we have a system that's big enough to do the whole house and we zone it, I'm still running a system that's big enough to do the whole house, even when I don't need to do the whole house. So it does cost more to do it that way, but if we explain it to the customer properly, they almost always go for that. like I just tell them, you know, it's not going to work as well if you don't do it this way. It's worth the additional cost. And if you've got them bought in on the process by that point, it's not that much of a larger leap to really do it right. The other thing is having a house. We have one that we're working on in Berkeley right now. That it's a 3-story house. Bottom story is a basement where the gentleman's office is. The mid-story is pretty big. It's about 1,500 square feet. And then the upper story is 2 bedrooms separated by a hallway with a giant skylight in the middle. And there's 2 attics that are not connected with each other. But there's a little area that goes over the bathroom that's about 2 feet wide to connect these 2 attic spaces. So talking to them about multi-zone and then going out and seeing how we're going to accomplish it was 2 very different conversations. But so what we ended up doing was we put the upstairs system. Let me think about this for a minute. We put the upstairs system and the basement system on 1 outdoor unit. So that was a dual zone outdoor unit. We would have done 3, but they just didn't have enough real estate on the side of this house for 3. We left the middle system. We did a medium, or not a medium setting, but an upflow air handler on the middle to replace the furnace. And then we orphaned the ductwork going to the various areas. And we put a wall mount unit in the downstairs basement office. We put a slim ducted unit in the upstairs attic with all new ductwork that wasn't coming through the floor. And then we orphaned all the ductwork that was kind of coming through the floor. And we put the right size system in the mid floor on its own system. And the reason that we did that, and the idea behind it was upstairs and downstairs are going to be not used together as much. So there's a lot of times when the guy is going to be in the middle floor or he's going to be upstairs, but he can't be upstairs and in his office downstairs. So we put a big enough wall mount head in his office downstairs that he could turn it on and it would heat the room up in a reasonable amount of time. But it's going to be very, very rare, based on our questions and him answering, that he is going to need to run the bottom unit and the top unit at the same time. So we don't have to worry about kind of sharing that capacity. We're going to see how that one goes. We sold that job, but we haven't installed it yet. So we'll see how that one goes. Another one that we're doing this week or next week is actually an inverter system. They have a typical single stage furnace. The house was built in the early 90s. They do have existing dual zone control. And we're putting in a manufacturer specified zone system, which is a special communication board and then special modulating dampers. And that manufacturer has that zone system that actually knows the communication language of the modulating system. So it will actually talk, and it's going to be in the conversation of the fully communicating system. So it'll make minor adjustments and release flow and do all these fancy things. But when we're doing a good heat pump for a customer, we need to make sure that we're putting in the most efficient system possible. And sometimes zoning those systems can be a bit of a hat trick. Now, there is a manufacturer out there that builds. They seem to have gotten a hold of all of the operating algorithms for several of the larger manufacturers, and they're actually building zoning equipment that can fit into the communication side of the system. So it's actually having input on how the unit adjusts its capacity as the zoning is working. That's kind of like an ultimate system. But once again, all these pieces are expensive. So we have to be very convincing in our conversation to the customer. But what we don't want to do, and I had not a colleague, but a peer of ours that also installs heat pumps that I was chatting with a couple of weeks ago, and they are taking the communicating modulating system. They're putting a low voltage or a traditional thermostat interface module and controlling the unit with that. And then they're running a zone control system through that interface module. So they're cutting the efficiency off at the legs on the system itself. And then they're running all of these regular analog thermostats and trying to make it work on this equipment. And he was asking me if I had any input on how he could make that work. And I said, the only way to make that work is not to ever do that in the first place. Like I would never even think of doing something like that. It's just, it just sounds in my head like it wouldn't work right, and it wouldn't be satisfying. And that's why he was calling, right? It's like, you have any ideas to help me fix this? But we didn't. So, okay, so that's a little bit of add-on extra content on this last slide. So let's right now have a little Q&A with our special guest, Randy, today. Now, I'm gonna let Randy introduce himself here. So I'm gonna stop sharing my screen, and then we'll both just get up on the camera. Randy, if you want to turn your camera on, I'm gonna stop my screen share. Hey, Randy, how are you?
I'm doing well. Thank you for having me on this today.
Absolutely. Thank you for coming on with us. And I met you not that long ago at a training, at a Mitsubishi training, and you were presenting on this problem that we always address with people, right? And
Yes.
we go out and reach out to these contractors all around, and we hear this, like, our go-to system is the 5-zone wall-mounted system. And then I think I mentioned to you one day we were having a meeting in the office, and some guy came in and he said, can you come over and fix this system that this other company installed? Because it's only like 3 months old and it has a weird smell. And so we were asking him, like, tell me a little bit about your system. And that guy originally contracted for a 5-zone system and then held off on doing 2 of the zones. So he had a big outdoor unit with 3 small units, and it was causing all kinds of problems. But so tell us a little bit about your background, Randy.
Let's see, been in the heating and air conditioning industry now for going on 26 years. Been working in the mini split industry, or for mini split manufacturers, going on for about 16 years now. I've worked for both Japanese and Chinese manufacturers. Currently, I am with Mitsubishi as an area sales manager. And in my time with mini split manufacturers, I've done everything from sales, tech support, in-house, tech support out in the field, applications training, product development, a little bit of everything. So it's a great industry to be in. One I'd recommend to a lot of people, but it's very exciting, a lot more technical than I think a lot of people would ever think.
I think that's right. And that's why I was so impressed when I heard your talk that day, was just you really got down into the technical part of it. And then when you told me you were a sales rep, I go, oh, no way have I ever had a sales rep that actually knew how stuff worked. I was really, really impressed, right? Usually sales reps, you know the talking points and how to get your contractors to buy stuff, but you had legitimate like knowledge about all this stuff. I was just so impressed. So
I also have some pains for the guys that do tech support, and they're always trying to fix the problem. So teaching the right and wrong ways to do it up front kind of eliminates a lot of the headaches in the back end.
It just saves a lot of time, right? So, and I was talking to actually the same guy I was talking to about the system, and he was saying that his guys spend a lot of time on tech support with the various manufacturers, and it kind of made me reflect of we've done so many of these and we've gotten used to them, and I wouldn't say good at them, bad at them, whatever, because when we install different types of equipment, we just get used to it, right? And so the guys are used to it, and we try to put them in right, so we don't spend a lot of time on tech support. So I only get to talk to you on stuff like this. So, so Randy, why do you think so many customers ask their contractors for these multi-zone, multi-room solutions?
Couple things. One, as Americans, we're used to always seeing grills and registers in every single room, so we have the idea that it has to be in every room. Two, I think our marketing departments, a lot of the manufacturers, have really kind of set the bar, because if you look at a majority of the advertising, when they show an example of a home, there's always multiple rooms shown, multiple evaporators shown, different set points. So the homeowners wanting that without really understanding what that entails and the problems that it can create.
Yeah, if it's not done exactly right, right?
Exactly. Yeah.
I'm always curious on, like, contractors might not know how much this stuff costs to install because it's so labor intensive and there's so much line material and all these things. And one of the things I always tell them is like, make sure you tell that customer that you're going to have this capping material all over the house. Otherwise, when they come home, they're going to be really surprised.
Well,
So,
people traditionally don't know what the cost of the individual zone is going to be, and when they get a ticket for 7, 9, 10 zones in the house, they're stunned.
yeah, it's nutty. So what is the system you've seen with the most zones attached to it? Like, have you ever seen like multiple branch boxes or anything like that?
Yeah, we've seen some houses done because the homeowner has said they want an evaporator in every single room. I've seen them up to 8, 9, 10 zones in a home, which is ridiculous.
It's crazy, right?
Yeah, I mean, don't get me wrong, unless the home is 20,000, 30,000 square feet, which we have seen those and it's required. But yeah, I've seen it in some very small homes where there's way too many zones just because the homeowner has demanded it.
So do you think that the contractors that are installing these understand like room by room loads and the implication of putting in maybe a wall mount that has a carrying capacity that's 3 times what the room load is?
Uh, First off, the majority of contractors really aren't doing load counts. They're just making some assumptions based upon, they think, well, I should say, let's go back to, most contractors are familiar with the single zone system, one-to-ones. It's a very common high wall where it's very, very forgiving on how it can offload. So a lot of those systems can drop down to about 30% of their rated capacity. So they make the assumption that the multi-zone is going to do the same. So as your example was, 6,000 BTU unit in a multi-zone system may only be able to drop down to 3,000, but in a single zone system might be able to drop down to 1,500. So they're making that same assumption that, I put a 6 in here, it's going to go to 1,500, but it doesn't. They don't understand the minimum capacity of the condenser, and it creates a lot of questions that they think it's going to be the most forgiving. And of course, in their mind, it's the easiest to install because traditionally a high wall, you're punching a hole in the wall, putting a line set through the outside of it, and like you said, put the line set cover on.
Yeah, so what are the things how do these problems show up? Like, how would the homeowner know they have the problem and call the customer? What is the symptom that they're going to see when these things are over?
Oh, it's real easy. They're going to overshoot, they're going to overheat, they're going to overcool, start manufacturing lots of humidity from cycling, large energy bills. I mean, but majority of the time, it's going to be overshooting traditionally in the heating mode. The room's going to get extremely, extremely hot, and they're going to know there's an issue.
Yeah, and that's what we've heard. So, and I've also heard like the smell that comes out of these things, like they call it the dirty sock smell. And we had, like I was saying, we had this guy come in and he was talking about a system that was very new, and it was ceiling cassettes, I think, but it's still multi-zone. But what causes that?
One, the humidity issue. What I usually find right off the bat where that comes into play is traditionally it's not the heating and cooling aspect. A lot of times we find dirty sock syndrome is other environmental issues that we run into, the things in the environment that are getting picked up in there. And of course, as we're creating a lot more humidity, better chance for mold, those kind of things to start growing in the system.
Interesting. And so if you have one of these units and it's running and it's creating humidity in the room because it's kind of cycling off and it's getting too cold, so I mean, you're going to hope that all that water drains out and goes out how it needs to.
Yes.
But if it cycles back up and the coil is still wet, I mean, is that something that happens or?
Oh, absolutely. Yeah, it can definitely happen there. And depending on what's going on with an extremely wet coil, you start running into issues of getting closer to icing the coil.
Mm-hmm.
So we've seen those situations happen before as well. So it's really what we're seeing is, from my standpoint, from my years in the industry, I typically don't get the humidity. We're pretty dry climate, so we typically don't get the humidity issue on our side out here too bad. Majority of the time, it's just the extreme overshooting of heating and cooling because these things aren't designed to adjust instantaneously. So if you had a set point, for example, of say 70 degrees on your system, by the time the system picks up on that and starts trying to ramp itself down, by the time it actually gets to where it's going to thermal off, you may be 10 degrees over the set point.
Yeah, and yeah, we hear that sometimes. So if someone wanted to go ducted instead of ductless, what do you think are the most important design considerations if we're going to size that system out?
Sizing is always important, regardless. For us, the biggest design considerations, I would say, on the ducted systems, from my understanding and from what I've seen, is finding out what the homeowner really is looking for in the ducted systems. Are they true? Because most of them, when they see the pictures of the ductless units, they want zoning of some sort. So I like to see the option of possibly multiple air handlers in a ducted situation, which reduces duct length runs, stuff like that, so less static pressure. You get more efficiency out of the duct systems that way. Those are typically what I see on the ducted systems as far as design considerations. Like I said, they're a little more forgiving because you have multiple rooms running. You're probably going to be closer in a range of that system is going to be. So we traditionally, at least on my side, I don't see a lot of oversizing or undersizing really with the ducted systems. They're a little more forgiving on the contractor standpoint.
Yeah, and I mean that's what we found too. And we were in a class last week, or we were talking to one of our cohort people or somebody, one of the contractors we work with, and he was talking about they're going to put a 9,000 BTU ducted in, and he's just going to put a 12-inch return on it and a filter grill. And I said, what you should do, and he says, because 9,000 BTU is only so many CFM. And I said, yeah, but we really need to make that return air as big as possible. What is the benefit of having the largest return on there? What does that kind of do to the fan energy?
One, less static pressure equals less power requirement on the fan. It's going to keep it quieted, that's for sure. Longevity on the fan, it's not going to be working as hard. Larger under returns like that, as you brought up, people are notoriously never changing their filters. I mean, I'm guilty myself. I get free filters, and my wife has to remind me all the time, 2 months later, that it's time to change them. So you don't get the buildup static pressure because the system's dirty. It keeps working longer and longer and longer, which is a really nice thing there. But from what I found, though, traditionally, it does keep the system quiet, which is what people really want.
Yeah. One of the things that we've noticed is when we hire a new installer and we bring them in, and they're kind of coming from the world of HVAC install, and they're always, putting in 4-ton furnaces with 14 by 24 return air platform grills, and they put one of the systems in with our guys, and they're like, I can't hear this thing running. So, oh my God, they go through that metamorphosis, right? I'm like, oh my God, this is amazing. I can feel it, but I can't hear it. And so that's one of the most beautiful things about these. And, I think Mitsubishi by far has probably the highest quality of any of these systems that we ever install. Like just the design and everything that goes into them is just superior in our opinion.
Yeah.
They work really well, like have so few problems with them. But let me ask you a question, like, and put your field service position hat on for a second. But what do you think out there in the world is the percentage? How many more ducted wall mount how many more multi-zone systems with wall mounts do you think are out there than ducted systems?
It's a vast majority more with ductless systems, just because that's how many. So many contractors cut their teeth on the ductless units. It's what they know. Also, for a lot of the companies that just big ticket jobs, it adds to the cost quickly. So, I mean, some of these guys are not necessarily looking out for the best. They don't have the best outlook for the homeowner. They're to sell something, make a big ticket item. But I would probably say, in my estimation, probably 85% of these jobs going out there for multi-zones have high walls on them. High walls, or like the ceiling cassette, one-way ceiling cassettes versus ducted.
Interesting. So What do you think about doing a multi-zone like an MXZ system with multiple like of the convertible air handlers, like the SVZ air handlers? Is that something that we should do or shy away from? Or
Personally, I mean, I don't have any issues. Actually, I kind of prefer having more ducted systems. And one of the reasons why is I think ducted systems offer better options on filtration, which is really important, especially somebody who has allergies. You can relate to that. The biggest thing is I find when we start getting into zoning, especially with some of the residential equipment, is people start putting in air handlers that are really drastically different in size and capacity on a single multi-zone system. And there's always issues of where they end up trying to isolate individual zones. And then, as you were mentioning, you have that system where it can only ramp down so much, and now you're overcapacitizing that air handler, and now somebody's too hot or too cold. It's the same. It's a little more forgiving than the ductless units because it's not directly in the environment, and you're sharing it out amongst other zones. But it's still a problem that's going to happen on the multi-zone systems, especially if the homeowner hasn't been told how the system works, which is what we find. I'd probably say about 95% of the installations where there's issues, it's because the contractors never had the conversation explaining to the homeowner how the system works, how they should run it correctly.
and I think a lot of that time is because maybe the contractors themselves don't understand how they're going to work until they're dealing with a problem later. Like that example that I showed you where we went from the multi-zone to the single zones, that was a very expensive problem to learn on, right? I mean, and a lot of those situations they never get learned on, right? There's some sort of a patchwork that's done, and the customer's just kind of stuck with that. Not a lot of companies are going to come in and say, we're going to spend all this money to make sure you're satisfied.
Yeah, one of the biggest things we see that people or consumers have in their mind is they're looking for zone isolation, not just zone comfort. So as your example of having the home offices, a lot of people working from home now have it in their mind, I just want to run the home office, then shut off the rest of the house. And they're not relaying that information to the contractor, so the contractor may think it's just for comfort. But yeah, the multi-zone systems really are not meant for zone isolation, especially in small zones. Now, maybe like the largest zone in the system, to isolate that and shut the rest of them off, not so bad. But then you also run into issues of the rest of the structure the other rooms are getting so far out of whack from the set point that when they actually want to use those rooms and turn them on, you're using a lot more energy to try to get back to temperature.
Yeah. I've seen them where it gets so warm in the room that you got to switch it back and forth between heating and cooling just because the system's like the wrong size, right? And then
Absolutely.
we tell people all the time, one of the benefits of installing a properly sized and installed heat pump is you don't have to fiddle with your thermostat anymore. And then putting a unit in where they have to fiddle with it more, that could be a problem, right?
So set it and forget it.
Yeah, set it and forget it, right? Like, who was that? The Ron Popeil oven. Remember those?
Yep.
What do you think of, like, we do a ducted system for the majority of the house and we put the ductless in one place. That's a pretty good solution for those two things. We could do that with the MXZ and not be a big deal. It's kind of two separate spaces, as long as we size the wall mount right?
Yeah, I see that. Actually, where I see that more often is not necessarily for the zoning aspect of it, but where I see it is the wife or person in the house who's really into the decor and look, just doesn't want to see them on the wall. So what they'll end up doing is, like in the main living area, they will use ducted systems and then go into the bedrooms or something like that. But they're not so concerned visually about what's up on the space. But as far as from a layout standpoint or a design standpoint, where that really comes into play nicely is sometimes you don't have areas where you can run the proper size ductwork.
Yeah.
So allowing those high walls or the non-ducted units and being able to get line sets over in those areas still allows them to maintain comfort in those zones. But again, we can run into situations if the zone's too small versus the smallest air handler, you're going to have the same overheating, overcooling situation if you don't have a good conversation with the homeowner and explain how the system works.
Yeah. Now, I think I was talking to you, and you told me that they're shooting for a 3,000 BTU air handler. Is that you guy?
But they are working on smaller air handlers, but here again, we run into the situation, if it's going to go on a multi-zone air handler, we can only turn down so low. And that's the situation that, yes, we'll have smaller air handlers for smaller zones, but you're gonna have to leave the system, all zones running so that the system itself can distribute the refrigerant amongst all zones and allow it to do its job.
So, what would you say is like a rule of thumb on sizing these multi-zone systems? Is there a certain point that we shouldn't size over? Because like in the example I was using, like we could put in an 18,000 ducted in that house. We did a little insulation, but if we put in wall mounts, it would be a 3-ton.
Yep.
And obviously, if we're going to do a load calc, it's going to be somewhere around 18,000. So, I mean, is there a rule of thumb that we should use to not oversize those?
Well, when it comes to multi-zones, traditionally on multi-zones, when you're doing that, we traditionally don't want to see the zones less than 50% of the size of the air handler. So example, the smallest air handler is 6,000 BTUs and the zone is less than 3,000 BTUs, start combining zones together to create a zone that can be controlled properly. Or if that's the case, I mean, if they have to have it that way, then maybe we look at offering a separate system for that smaller zone. So that way it has a larger capability of turn down.
Yeah, and we've done that a couple of times where we just put the little 12,000 ducted over the 3 bedrooms and the bathrooms.
Yep.
And then we'll do the other ones that way for exactly that same reason, right? Well, and then all the other reasons like refrigerant and piping. So
yep.
if I'm installing like an MXZ 4-ton with a branch box and I've got say 100 feet of pipe on that, how much refrigerant do you think that thing holds?
Oh man, there's going to be quite a bit of refrigerant, and which creates its own set of issues, especially now that refrigerant prices are going through the roof. But what it really changes up when we get into the next refrigerant release, some of the new refrigerants coming out, the A2Ls are going to be slightly flammable. So now we got to have other parameters coming into play later on where we're going to have refrigerant leak sensors, specialized valves, all kinds of stuff. So, I mean, one, it's cost, more chances of a leak, which is going to be problems down the line. But I mean, that's really where you're looking at it. It can be a considerable amount of refrigerant. Like you said, I've seen some of these systems where it's well over 20 pounds going into it.
Yeah, and that's crazy. Like if that thing went flat out of warranty, that could cost the customer a couple grand to get it recharged, right?
Oh, absolutely, absolutely.
Yeah, it's kind of insane. So, what do you think of the VRF technology, and when is that a good option?
VRF. So when people kind of traditionally refer to VRF or VRV, both just basically industry trade names that people use on more of the commercial grade equipment, but they actually mean the same thing. Traditionally, where that comes into play for us in the residential is when we need larger pieces of equipment, we need larger duct runs. Traditionally, those systems allow for more advanced controls integration. So sometimes people may want to have more of a building automation system in a residential design, start tying in the Crestron, Lutron, some of the home automation systems. That's where they typically come into play. But some of the other benefits of the commercial products is they traditionally have a wider range of offloading capacity on them. And traditionally, the air handlers are a little more efficient because we're putting the expansion valves at the air handlers. So you're getting true control right at the air handler, not at a midway point or at the condenser. But the one thing to note is on the larger commercial equipment going into residential applications, it's traditionally noisier if you use high walls or anything that's actually physically going to be in the room. It's going to be a much louder piece of equipment because that expansion valve is right there in the environment as well.
So you're going to hear like the hissing and the fluctuating and the kind of the the fish tank bubble kind of sound or whatever.
Yeah, and in some instances, sometimes you can even hear some clicking.
Awesome. I put in a multi-zone system a number of years ago, and I wanted ductwork, but she didn't like the smell of the inside of the ductwork. So just setting the parameters. So, and then we put these units in, and she was having an issue that when she ran the unit in her master bedroom, the unit in the kids' bedroom would make like a popping sound.
Yes.
And my theory on that was that the refrigerant was flowing in there and the cabinet was just expanding. Do you think is that what it is?
Yeah. Actually, it's funny. We were just in the works of updating our design applications class, and that's one of the things we're talking about is popping, cracking, creaking. What we traditionally find is you never hear those noises until those individual zones are off. Because other than that, there's traditionally a little bit of a white noise going on in there with the fan moving and stuff like that. Yeah, that's typically when you pick up all those noises. Is when the system's off, you will hear some cracking, some creaking, some of that hissing or bubbling, like you mentioned, from a little bit of the refrigerant bleed by going through. And it's when you can definitely hear it.
Another thing that we found on one of those that was making a weird noise too was the mounting plate wasn't perfectly flat,
Yes.
and it was like it was tweaking the cabinet slightly, so it was doing weird expansion and contractions.
Yeah, we've had that before with the contractor. They look to make the unit level on the wall, but they don't actually make sure that the wall's perfectly flat because the backing plates on these things are relatively flexible. The bodies are made with plastic, a little bit of metal, some styrofoam, so you can actually tweak the evaporator to snap it onto the bracket, and the next thing you know is you got the blower wheel out of alignment. So now you might pick up some clicking and start making some really odd noise, especially under expansion contraction.
Yeah, so it comes back down to being careful, right? So
installation practices.
Yeah, you got to get the long level so you can make sure it's straight, but also lay it on the wall and see what's going on, right?
Yep, no, nobody ever does that part, especially actually, and typically where that's missed is the sales process. Consumer says, I want it on this wall. The sales guy's not going to go in there to make sure the wall is level ahead of time to, tell the homeowner, this is not a good location for this thing because your wall's not level.
So how important is it for the consumer or the salesperson to consider having these on outside walls for natural draining versus using a pump on an inside wall?
Avoiding a condensate pump is the best practice in all applications, but it may not be the prettiest situation. A condensate pump is a failure point because, as we talked about, people don't change filters. Nobody services a condensate pump until it breaks. It's just nothing that they ever think of. But then the other side is condensate pumps will make considerable amount of noise even when the system's running. You'll always pick up the vibration noise or the buzzer.
Yeah, I noticed. I have one in my office here. I don't know what brand or what kind of pump it is, but I've been surprised at how little noise it makes. We have another one in the other office, and it's kind of an inside wall, but it's connected to our warehouse. So there's just a line that goes back and it goes into a traditional condensate pump, and you can hear that thing running. So the
ones meant for mini splits are quiet from a standpoint of what else is out there in the market for pumps in general. But once you get into the bedroom and somebody's trying to sleep, they're going to hear it.
Yeah. And we've gotten a noise complaint from a customer on that too, and we had to go and mess around with it. Found out that the pipe was actually the problem with the pump was there was a little kink in the tube coming out. It wasn't pumping out at its fullest point, and it was making the pump loud. So one of those things you got to go, why is this doing this, right?
Yep.
Finally, the second technician out there figured it out, and that's always how it goes too. So, so can we put traditional zone control on like a ducted Mitsubishi system or any of these inverter systems, and what should we watch out for on that?
So different manufacturers, different rules. Traditionally, when people are putting traditional style damper systems on the ducted units, it's through the use of third-party thermostat adapters, which are already kind of dumbing down the system itself. I've seen with a couple different manufacturers, including ours, that you start losing some of your indoor fan speeds when you start using the system. So again, not only are you losing some of the inverter capability, you're losing some of the fan speeds. It's an option. I like, if you want separate zones, get separate air handlers. It's the right way to do it. I mean, if you got to make air in a certain spot, why would you make air, for example, in the garage and push it all the way upstairs? When you can make air above or in the second floor, shorter duct runs, save energy.
Yeah.
And let the system do what they want. There are some manufacturers, like you brought out, that have worked with the ductless manufacturers, so they actually talk and keep the full algorithms going. The price points are very, very high.
Yeah, anytime you get that.
So the other thing to remember too is when people start getting really crazy, we mentioned we have some situations where I see 8, 9, 10 evaporators on the system. Sometimes it gets down to where the homeowners or the designers are wanting to put ducted zone control on top of multi-zone control, which is a big no-no. So, I mean, it can get to be a real design nightmare at that point. My personal opinion is, if you are going to play that game of using kind of this non-proprietary zoning system on a ducted system, never do it on anything but a single one-to-one system, and try to keep it no more than 2 zones.
Yeah, absolutely. I mean, I'm just afraid of doing that. Like, I never really liked the traditional zone control on the old furnaces back in the day for all the reasons we talked about earlier. So it just scares me to, like, I'm going to take this kind of dumb analog technology and kind of bolt it to my super computerized system. And it just seems scary to me.
So,
all right, Larry, just a time check. We're right here at 1:30, right at the end of the webinar slot. So just want to check in with Javier, see if we have a couple minutes. Otherwise, we can start leading towards wrap up.
Yeah, we have a couple minutes. I see a question here from Paul in the session, if we want to address that and wrap it up with final remarks and maybe final questions. But
let's hear that question, Paul.
All right, I'll go ahead and read it off. So from Paul, if a homeowner already has a multi-split system, what's the best advice you'd give about operating the system?
Go ahead, Randy.
For me personally, if you already have a multi-zone system, is one, understanding what the lowest point or the lowest BTU output your outdoor unit can ramp down to. Know the size of all your individual zones, and understand that if you do want to start isolating zones, to understand which ones need to be running together to make sure that you don't go below your minimum output of the actual system. But in reality, I like to say, find your temperature, set it, and forget it. I mean, if you got to have some slight variations between zones, that's great. Be realistic. I mean, don't go 6 and one at 75. That doesn't, I mean, you're not helping yourself. A couple degrees between zones is fine.
Absolutely. That's sage advice from a true professional that knows this stuff from the inside out. Randy, thank you so much for joining us today. It's been incredibly enlightening.
I appreciate it.
As always, it's a pleasure to see you, my friend. And I think I think we kind of ran out of time. Any last words you want to put out there of advice that
if you're looking to buy a system and your contractor doesn't do load calculations, find another contractor.
Sage advice from a guy that knows. All right, yeah, you're preaching to the choir on this end, but I think everybody out there needs to hear that. So, hey, thanks everybody for joining us today. This was a really good one. Thank you so much, Randy, for coming on again, and Javier for putting this last one together. Happy holidays, Merry Christmas, Happy Hanukkah, whatever we got going on out there. Be safe the rest of the year, and we will see you guys in 2024.